And good morning, everybody. Hope you're doing well. Mr. C coming at you all the way from my house and my garage. Starting to be a little bit quiet this morning, but I want to let you know what's going on when I'm not there today and you're working with Miss Soon. You'll see two new items in Canvas. You will see percent problems for Halloween and the paper jam problem, which is an assignment. I'm going to expect you to take a crack at as many of the percent problems as you can today, as well as the paper jam problem. I want to talk about percents and show you kind of an easier question to get you thinking about how to solve percents. We already know a lot about proportions, and so I want you to take a look at this problem here. There are 30 houses on a street. 24 of them have pumpkins on their porch. I know that you liked that I made that a Halloween-themed question. So the question is, what percent of houses have pumpkins on their porch? So what we need to think about when we think about percents is part to whole ratios. That's what we're thinking of, part to whole ratios. And so what is the whole here? Well, the whole is 30. There are 30 total houses on the street. What is the part? Well, 24 is the part that have pumpkins. So 24 is the part and 30 is the whole. So then thinking about what percent that is, if you remember the definition of percent, percent means out of 100. So if I look over here, 24 out of 30. Well, let me go back to my previous slide. Part to whole equals a certain percent. Or you could think of it as part to whole equals that percent out of 100. That's a great way that we can think about percent. Part to whole equals the percent, or part to whole equals the percent out of 100. Okay, on to our problem. Here we have the part, 24 houses out of 30%. Out of 30 houses. 24 houses out of 30 houses equals what percent? Well, you can think of that 24 out of 30 as what out of 100. And the easiest way that I can solve this question, but this is not in any means the only way, is I'm going to look here at the relationship between 24 and 30. And I know that 24 and 30 have a common factor, and that common factor is 6. So I'm going to take that and divide it by 6. Take that and divide it by 6, and you can see down at the bottom here what happens. If I take 24 divided by 6, I'll get 4. If I take 30 divided by 6, I'll get 5. So now I know 4 out of every 5 houses have a pumpkin, and if I'm trying to figure out how to get to 100, I'm sure that you can see the easy between ratio here to get from 5 to 100. 5 times what equals 100? Times 20, and so 4 times 20, we're going to do the same thing to the top, is going to give me 80%. So what percent of houses have pumpkins? 80% of houses have pumpkins. Okay, that's just an example of a percent problem and how to solve it. A different percent problem might involve us knowing a different part of the problem. So take a look at this one. The PTA reported that 75% of the total number of families were represented at the meeting last night. If children from 320 families go to the school, how many were represented at the meeting? Now in this case, you know the percent and you know the whole. What you're missing is the part. How many families were represented? So again, going back to our slide, we know the whole, we know the percent. What we're missing is the part. And one of the ways that you can solve this is a proportion. It's again not the only way, but it's one of the ways that you can solve this. So we know that 75% of families were represented, and that is a certain number of families out of 320. Well, if I understand that percent means out of 100, I can say that 75 out of 100 equals a certain number out of 320. I'm sure you know that there's a relationship between 75 and 100, that they also have a common factor. I can divide both of those by 25, because 25 is the greatest common factor. And so if I do that, I would get 3/4, right? 3 out of 4. So 3 out of 4 families were represented, and 3 out of 4 equals what out of 320? Once again, we end up with a nice between ratio proportion to solve. How do I get from 4 to 20? I multiply it by 80. So what am I going to do to 3? I'm also going to multiply it by 80. And 3 times 80, mental math, is going to give me 240. So how many families were represented at that meeting? 240 families. All right. So that's 2 examples of how to solve proportion percent problems. Not the only examples, and those were kind of easy. What you'll find today is you'll have a couple of different assignments. The first thing that I want you to do is I want you to check out this PDF. It is on Canvas. Where is it on Canvas? Well, if you go to percent problems, this is in my ratio and proportions module, in percent problems, what you'll see here is a message from me. Good morning, 7th graders. Today you'll use your knowledge of proportions to solve problems involving percent. Keep in mind you don't need to use proportions, but it's one method that works. If you need help, you can check out Khan Academy. There's a lot of work on Khan Academy for percent word problems. This is what it looks like right here. I got this into math by grade, 7th grade. This time I'm in fractions, decimals, and percents, percent word problems. If you need practice, there's 4 videos here, and there's a couple of different practice problems. Then, you can actually solve these problems using a variety of methods, and I'll leave that up to you. You'll be asked to solve problems without a calculator, so please try to do so. And you can use Desmos.com if you must, but try not to. So here's the link to the PDF. And this PDF you can find right here. It looks like this. It says Fluency with Percents. It asks you to solve the first problem using mental math. I honestly think that you can do these mental math. But if you need to, you don't have to. And then you'll see some more mental math problems. There's actually a bunch of different problems here. Some of them involve some unit conversion. What is 9 hours as a percentage of 3 days? That's a great question. You obviously have to know how many hours there are in 3 days. Or, Richard works from 11 a.m. to 3 a.m. His dinner break is 75% of the way through his work shift. What time is his dinner break? Well, you'd have to know how many hours long his work shift is. Anyway, there's a bunch of different problems here. I want you to be able to work with a partner, or you may work by yourself on all of these problems. Okay? There's a lot here. I really like this problem set. I think these are really good problems. Some of these you're probably going to need a calculator for, but I honestly think that you can do it without. Okay, so that's the first thing on Canvas, percent problems. I don't expect that you're going to get all of them done, but I want you to try as many as you can so that you feel comfortable solving percent problems. And then, as an assignment, I'd like you to solve the paper jam problem. And you'll find that right on Canvas as well. So, underneath percent problems, you'll find the paper jam problem. And the paper jam problem looks like this. Oh, it didn't open very well. So let's see here. I want you to be able to see the problem itself. And once you've done some percent problems from Engage New York, try to answer this question based on this advertisement. Okay, this ad says that the paper, Hammer Mill, is 99.99% jam-free. So, what does that mean? And how many paper jams would you expect from this giant crate of paper? You can see this in Canvas a little bit more easily when you open it up. But there's a lot of paper here. And if this is 99.99% or 99 and 99/100% jam-free, how many paper jams could you expect from this giant crate? And there's some information here to help you. And I'll give you a hint. You're looking at the information that can help you right here. Okay? So I'm going to ask you to solve this problem. I'm going to ask you to record, just like I'm doing, your answers to the problem. And you're going to upload those on Canvas today. Do not use your phones. Use your computers with Canvas. You can work with a partner, so you'll need to do one person out of 2 doing the recording, but I want to see both of you in the recording. That's what it says right here. Okay? When you're done with that, you can go back to Khan Academy. Make sure you're on task all day. I want a good report from Miss Soon. All right, good luck. Again, do your best on the percent problems. Do your best in the paper jam question. Record yourself. Do a good job. And I'll expect to see excellent thinking and excellent reasoning. All right, take care.